All right, here's a literal equation where we have xy minus b over c equals bx, and we want to solve for b. So first, I'm just going to rewrite this to give myself some more space down below. Xy minus b over c equals bx. Now it's important to note that b shows up multiple times already here, so that's going to make things a little bit trickier. I have a b here and a b here. My overall goal is to end up with just b equals a number. So I want to see b equals something where that something has no b in it. I can't have b in my answer. If I want to solve for b, I can't use b to find b. So let's get started on this one. We're gonna, as far as a process, we want to get all the b's to one side. And then we're going to end up factoring out a b. And in general, whenever you have more than one of the variable that you want to solve for, you're going to have to be doing some sort of a factoring so you can just boil it down to one variable. So let's start off by, let's see, well, we can start off a number of ways, but what I'm going to do is I want to get rid of this c in the denominator. So I'm going to start off by multiplying everything by c. Now the reason I'm doing that is because that's going to eliminate this fraction, and that's going to make life easier for me. I don't have to worry about common denominators, anything like that. So now this is legal because I can multiply, as long as I'm multiplying everything by c, everything staying proportional, everything staying equivalent. So now I'm going to have to distribute that c to every single term. Every term needs to get multiplied by c, not just this one, but everything. So I'm going to have a cxy minus, and this is bc over c, equals bcx. Now what's convenient about this is that these c's cancel, and let's see, let's just write that one more time. So I've got cxy minus b equals bcx. Alright, so now let's get all the b's to one side here. So I'm going to add b to both sides. This goes away, so I have a cxy equals b plus bcx. So this is good. I have all of my b terms over here, everything else over here, and at this point I'm ready to factor out the b. By factoring out the b, I'm going to have just one b left in this equation and no longer two. So let's see, let's go up here. And I have cxy, that's the same. That's going to equal b. Now if I factor out a b, remember you're thinking kind of like reverse distribute, take out b from this and from this. It's like a greatest common factor. So when I take a b out of b, I have a 1 left. And when I take a b out of bcx, I have just a cx left. And don't forget, you can check to see if you factor this correctly by just kind of redistributing this back in your head. If I were to distribute the b, I would get b plus bcx, and that's what I started with. So we're good. So now that we have the b factored out, all I need to do is divide by this 1 plus cx factor here. This is joined by multiplication, so I can divide by this whole factor, and I can divide by this whole factor, 1 plus cx. This cancels, and what I'm left with is, and I'm just going to switch sides here, so I've got b equals cxy over 1 plus cx. Now, if you're thinking that you might want to cancel the c for the c or for the x, be careful of this. This is an entire quantity, so I can't get inside of this quantity and start canceling things out since I'm adding these terms together. Only if I were multiplying these things could I cancel any of these out, but this is one quantity in the denominator, so I'm going to have to leave it just like that. And there you have it.